I'm Jack. Thank you so much for coming to my talk. This is something I'm really passionate about. You're going to learn a little bit about cloud engineering and platform engineering, and we'll sort of tie it into how Airflow works. But before we get into that, I'm a senior platform engineer at Propel. If you don't know us, we're a fintech company based in Brooklyn, and we build modern and respectful technology for low-income Americans to help them better their financial health. So if you're interested in that, please check us out. And with that, let me jump into sort of what we'll talk about. Again, the Bronco tool came about in sort of an interesting way from a platform engineering team. And so to introduce it, I'd love to talk through a little bit of cloud engineering, Terraform, and platform engineering, give you guys a little bit of an introduction to that. And then we'll talk about how sort of Airflow ties into all of it. So as most of you probably know in this room, like nowadays, software companies do not buy any silicon, really. We instead rent them from public cloud providers. So Amazon Web Services and Microsoft Azure are the two biggest of those. And we often need a lot of different types of hardware. So we need databases, we need queues and compute. And so a lot of the hardware that we are renting, we've turned to automation. And specifically, we've turned to infrastructure as code tools in order to sort of automate that rental process and that hardware configuration. And the leader probably in the IAC tool space is called Terraform, built by HashiCorp. Terraform is a pretty neat IAC tool. It's probably the chief thing about it is that it's declarative. So if you're familiar with like Ansible or Chef, you're typically writing sort of bash steps of how to configure your infrastructure. But with Terraform, you're just declaring the infrastructure that you want. And aside from that, there's a state file that basically tracks the infrastructure you have. And so when you run Terraform plan or Terraform apply, you're comparing those two things, what you want and what you have. And Terraform sort of takes care of getting you the infrastructure that you'd like. Terraform file looks something like this. So in this case, we're just creating a S3 bucket. And again, you can see that we're just declaring the bucket. We have the name, we have some tags, but we're not actually writing any of the steps that it takes to create that. All of that sort of abstracted away into what's called a Terraform provider. But I guess what's important for this talk is that there's a lot of different types of resources that you can create with Terraform. So this is just one resource in AWS, but it can plug into pretty much any provider. And AWS alone has over 200 different services that you can provision. And so there's sort of a lot that goes on. And so that's why a lot of companies have turned towards platform engineering. The idea is to basically abstract away the complexity of cloud computing. And a platform team basically has a couple of responsibilities. They, first of all, offer some products. So they will offer platforms like compute, platforms like databases. We talked about queues earlier and a bunch of other services. And the responsibilities with all those products is things like security, monitoring, availability, and probably most of all, maintenance. And maintenance is really bolded because it's probably the single largest thing that slows down really any software team, but especially platform teams. It always seems to grow non-linearly. So the more software that you're managing, the even greater maintenance you have. I like to say it's tedious and almost repetitive. And that's, a reflection of just how differently different teams can configure things. And so it makes it a bit of a challenge to sort of automate maintenance. And for a platform team especially, but really, again, for all teams, you have to perform maintenance with a high degree of confidence, especially in production, and probably quickly and at scale. So, you are often performing maintenance in small time frames, late in the day or over the weekends where people aren't using the service. But for a platform team, maintenance can really limit team velocity and limit the amount of scope that the team can take on. So one case study that I'd like to talk about, we'll call them the orange team. It sort of speaks to how this maintenance can overwhelm and limit platform teams. So this is a team that actually existed. It's a team that I consulted for, and they were a really successful enterprise platform team. They offered basically a self-service website where you could go and click around and demand sort of a Kubernetes deployment or spin up in a database or a queue, and it all used Terraform behind the scenes. And they existed for about 5 or 6 years before I came across them. They grew to support tons of different teams, probably 50 or so engineers, 1,500 Terraform deployments, tens of thousands of cloud resources, so a pretty large scale team. And it was fairly good. The only problem is that over time, that maintenance and that technical debt sort of accumulated. So a lot of their code was built and deployed using Terraform version 0.11. And for those of you not in the space, that was released around 2017. I think the most recent version is 1.9. So they've gone through at least one major version change and a few other sort of non-compatible, non-backwards compatible changes since 0.11. And so upgrading it was kind of a hassle. And the sort of impetus for upgrading it was that the platform team wanted to start introducing static code analysis. So being able to sort of detect in the Terraform code if you have security vulnerabilities, maybe like a public S3 bucket, and that required at least Terraform version 1.0. So they were really struggling with this, and the sort of approach, I was just telling Derek, that sort of the approach started with trying to automate some of these upgrades, and we started to realize that it took a bit too long to do them serially. Again, with over 1,500 deployments, small windows to upgrade, we realized we started to have to parallelize them. And then the issue with sort of running all these different threads with these different upgrades was that we'd have some start to fail, and we'd have a lot of trouble sort of tracking the logs and figuring out how to restart, sort of an idempotent DAG. So that's sort of where we stumbled upon Airflow as a way to sort of manage all this parallelizing, all these automated tasks for upgrading code. And Airflow has a ton of advantages over just sort of programming your own multi-threaded automation tool. You get sort of a very nice scheduler, you get a beautiful UI, and the ability to sort of track all the different tasks that are running, see the logs, and also retry from the point of failure, which was big for us. Some of these upgrade jobs could take 30 or 40 minutes, and having to restart that towards the end was a real hassle. So that's basically what Bronco is. It's a task and code base built in Airflow, and it's designed to automate the administrative duties of a platform team. And what we found out is Bronco really enhances a platform team's velocity and the scope of infrastructure that they're able to maintain. So I've got a fun demo for you, and let's switch over to that. So the demo basically follows not Terraform upgrades, because I've done enough of those for a lifetime, really, but it does follow a platform team that's managing S3 buckets. And so we've got 10 or so different S3 buckets here, and inside each S3 bucket, we actually have a password.txt file. And the problem that we've encountered is that these S3 buckets have been provisioned incorrectly. So we've forgotten to block all public access. So all these S3 buckets are available. If any of you in the audience are on your computer, my challenge to you is to try to get this password.txt file before we're able to patch it out. So the idea here is that this code is already managed by Terraform. We have the sort of repo here, and we've already got the patch prepared. You can see that we're reverting the commit that made the buckets public again. And we sort of saw what the Terraform code looks like for an S3 bucket earlier. This is very similar. This is the S3 bucket public access block. And we are basically going from public buckets to non-public buckets. So we already have this code committed. It's version 1.2.1 of this project. But the problem is that we have a whole bunch of different deployments of this code. And so you can see this is sort of deployments 0 through 10 or 0 through 9. Each one of these has their own bucket name, their own parameters, et cetera. And so the challenge is, how do we deploy this quickly to all these different buckets? And so that's where this Bronco DAG comes in. We've got a DAG that has 3 different blocks. Setup is sort of a generic workspace initialization. Clone is to basically clone the project down. And then lastly is apply, which has most of the business logic for performing the Terraform deployment and infrastructure rollouts. And if we run this DAG, you can see what some of these parameters are. We've got the URL for the repo that we want to apply, the branch or the tag of that URL, the Terraform version that we're using, and the actual deployment name. And so rather than trigger this tag a bunch of times manually, I've actually got a small script that we can run. This script will basically just loop through and kick off that DAG, as many times as you need. We'll go ahead and run that. And if we hop back here to Airflow, we should see a number of our apply jobs running. And now you'll see that this is sort of the issue that a lot of platform engineers run into, is that some of these are failing, and it might be from different configuration or network outages or things like that. In our case, we can take a look at the logs for this particular job that's failing. Okay, so in this case, we've got a really bad luck exception. And one of the reasons I love that is actually this task skill check basically rolls a dice through 1 through 20. And you only get a really bad luck exception if you roll a 1. So we actually, that's pretty surprising that we've got that one. But in this case, if we have a problem with one of our tasks, we can go ahead and clear it and just rerun it essentially. And so this is really the advantage of using Airflow, is the ability to sort of pick up from point of failure. You can modify tasks on the fly. You can really handle a lot of different scenarios, a lot of different failure scenarios. This one failed again, but that's okay. We'll leave that one open. So the only other thing I want to point out before jumping back to the slides is what one of these tasks look like. And so here you can see a task called apply. And the thing I want to point out is that it's pretty reusable. So we've got basically just a function. It takes a version, current working directory, options, and environment. And the really neat piece about Bronco and Airflow in general is if you construct the tasks thoughtfully, you can reuse them sort of across different DAGs. And what that really allows you to do is it allows you to reuse a lot of code. And so I think that's sort of the unexpected advantage that we encountered with Bronco, is that the code base actually grows over time. And as you construct these little building blocks, you can do more and more sophisticated things with them. And so even though maintenance can grow non-linearly, with Bronco, the tools to tackle it can also grow non-linearly. And it really sort of evens the playing field. So in summary, Airflow is more than just a data tool. It is really like I said in my prompt, a job scheduler on steroids. It's a workflow management tool. It really allows you to configure and tackle a lot of different problems. And the investments in it pay dividends. So that's sort of all I have for you. If you're interested in reading more, there's actually a whole blog post that I put together on this. You can scan the QR code and check it out. But otherwise, thanks for attending.